Good morning, afternoon, or evening. How y'all doing? Welcome back to Mr. Morrow's geometry class. How's everything going today? Today we are going to start learning about proofs. And proofs are actually really cool when you think about it because you're going to show the reader and yourself, more importantly, step by step why something is or why it is not. And it's not going to be, oh, because I think so or because it looks like it. It's going to be proven. Hence the word proofs. So let's just all relax. Let's take a deep breath and let's just focus today. Ask any questions you need. I want to make sure that I do the best job that I can. Okay? So today we will begin working on two-column proofs. In other words, in order to prove something in geometry, theorems are going to be used. You're going to be using theorems, definitions, postulates to prove things, okay? What is a theorem, though? Well, a theorem is a mathematical statement that can be proved, okay? It's a mathematical statement that can be proved. It's that simple. If you can prove a mathematical statement, that means that it is a theorem. Now, we're going to be learning theorems, and I'm going to teach them by theorem 1 or 2 or 3 or 75, theorem 122. There's a lot of theorems. You cannot, I repeat, you cannot say to me on a proof, theorem 1. And I'll explain to you why. Geometry, in any geometry course, you're going to learn this theorem, which is called the right angle theorem. That's the name of the theorem, though, not theorem 1. Because in another book, maybe that's theorem 5. Or in another book, maybe that's theorem 3. So saying theorem 1 isn't consistent mathematically throughout the world. But the right angle theorem, that's consistent. Okay? And what is the right angle theorem? Well, it's very simple. The right angle theorem states that if two angles are right angles, then they are congruent. It's literally that simple. If you see that two angles are right angles, then you know that those two angles have to be congruent. Why? Because right angles mean that they have 90 degrees. And if you have two right angles, that means that you have two angles that are each 90 degrees. If you have two angles that are each 90 degrees, guess what, y'all? It is congruent. They are congruent. Okay? So, let's start with a little proof as to how this is used. When you are going to be proving things, we're going to primarily use the two-column proof. We're going to learn later on this week, that we can do something called a paragraph proof. It's really up to you, but the two-column proof is more concise, it's quicker, and it gets to the point immediately. Okay? So this is the way the proof is set up before I even get into it. Notice how you have two columns here. You have statements and you have reasons. You cannot put a statement down without a reason. Why? Because that's just the way it goes in geometry. You cannot say, oh, because I think so. Oh, because it looks like it. You have to be able to prove it. So let's get right to it. In any proof, they are going to give you a given and then something that says prove. Sometimes in some books it says conclusion. Either way, the conclusion or prove means the same thing. It means this is what you're given and this is what I'm trying to prove. So, first thing you're always going to do, no matter what, if you can do this, you're going to get at least a few points on the proof. I promise. Write down the given information. And from the given information, then proceed to see what other theorem or definition or postulate I can use to continue my proof. So here, the given is that angle A is a right angle. Okay? Angle A is a right angle. And I forgot another given. A second given, I apologize, is that angle B is a right angle. I got to make a little typo here. So sorry about that. Okay. So if angle A is a right angle, why? Because it was given. Literally. They gave you that information. Now, from here, what do we know about right angles, guys? They're 90 degrees. So guess what? Follow the pattern of thought. Since angle A is a right angle that was given, I know for a fact we already learned the definition of right angles. And the measure of angle A then has to be 90. Why? If an angle is a right angle, then its measure is 90 degrees. I am not a stickler for having to explain every theorem word for word. I am a stickler, though, for you understanding the concept. So if you really think about it, we already defined right angles as angles that have 90 degrees. So you can write definition of right angles. Because already everyone in this class hopefully knows the definition of a right angle means that it's 90 degrees. So you don't have to write every time, if an angle is a right angle, then it measures 90. If you like that, awesome, cool, go for it. But you can write, in this particular case, definition of a right angle. If anyone is confused, again, why? Why could you do that, Mr. Moore? Because you know the definition of right angles. The definition of a right angle is an angle that measures 90. Next step. That's about all I can take from the given information at this point. Step 3. Angle B is a right angle. How do you know? Because it was given. And if angle B is a right angle, y'all, what do we know about the measure of angle B then? You're absolutely right. The measure of angle B equals 90 degrees. Why? Thank you, son. Definition of right angles. That's simple. Now that we have defined and proven that angle A is equal to 90 degrees and angle B is equal to 90 degrees, what can we say about two angles that have the same angle measure? That they're congruent, and guess what, my brothers? That's my proof. Angle A is congruent to angle B. Why? If two angles have the same measure, then they are congruent. And that's a proof. There's no question to any reader out there about that. No one can argue that because it is proven. Does that make sense, y'all? Awesome. Now, theorem 2. We're talking about the straight angle theorem. Now, think about what we just defined as the right angle theorem. What would you think the straight angle theorem states, guys? Any thoughts at all? There's no right or wrong answer. Well, there's a wrong answer, but anyone want to try? You are on fire, brother. Straight angle theorem is very simple, just like the right angle theorem. If two angles are straight angles, then they are congruent. Okay? If you wanted to, you can go ahead. Well, we'll get to it now in the proof. Okay? Two angles are straight angles, then they are congruent. Does it make sense? Okay. Let's look at our next proof then. Angle ABC is a right angle. And angle DE is a straight angle, sorry. And angle DEF is a straight angle. I want you to prove that ABC is congruent to angle DEF. So sometimes they don't give you a drawing. So make one. Angle ABC is a straight angle. Awesome. A, B, C. It's a straight angle. DEF is a straight angle. DEF is a straight angle. I want to prove, bless you, son, that angle ABC is congruent to angle DEF. So we're going to always start with our givens. Yes, sir.
So angle ABC.
Correct? You're on fire. Angle ABC is a straight angle. Reason given. What do we know about the definition of straight angles? Yes, sir. That is exactly correct. The measure of angle ABC then equals 180 degrees. Why, my brothers? Why? Thank you. Definition of a straight angle. Now, if you wanted to, you could say, if an angle is a straight angle, then its measure is 180 degrees. You can do that, but I'm not here to torture you. I want you to already know that definition. Oh yeah, straight angle has to equal 180. So the reason that angle ABC equals 180 degrees is because definition of straight angles. Number 3, what do you think would be next? Sir? That's exactly correct. Angle DEF is a straight angle. Why? It's given, absolutely. Always write at least your givens, guys. Always. You're going to get some points at least that way. So if DEF is a straight angle, what do we know about the measure of angle DEF? Yes, sir. The measure. Yes, sir. Always remember, great job. Always remember to put that little M. That little M says the measure of angle DEF equals 180 degrees. That's exactly right. Why, sir? Yes, sir. What's up? Okay, does it matter which order? Well, kind of. I mean, some people write out all the givens first, and then they expand upon it, but I find that sometimes that could be a little tedious, especially if you have 12, 10, 15 different lines of proof. So what I always do is, I always write my first given. And then I say to myself, okay, what does that information, how does that information help me? How does knowing that angle ABC, for example, in this particular case, how does it help me knowing that angle ABC is a straight angle? Well, the only thing it tells me is that the measure of angle ABC is 180. Now you're done with that given. Now you can move on. So there's different schools of thought. Some people write all the givens down immediately. You can. There's, nothing mathematically wrong about that. However, logically speaking, the whole point is to have a given. Okay, how can that help me? What does that tell me? What does that give me? Have a given. Okay, how does that help me? What does that tell me? Thank you very much. Now, the measure of DEF is 180. Why? Definition of straight angles. Sir. Sure, and then what's number 5, my man? You're almost on. No. You're right. I'm going to let you continue. The only thing you had said, my man, is you said measure of angle ABD and measure of angle DEF. The measure was given here. Okay, we did these two measurements in order to prove congruency. We know that 180 is equal to 180. But at the end, they're not asking if the measure of the angles are congruent, just if they're congruent by themselves. So take off that measurement part and then repeat what you were going to say, my man. That's what I'm talking about, because that's what I'm trying to prove. Angle ABC is congruent to angle DEF. Excellent. Why, my brother? Absolutely, brother. If two angles have the same measure, they are congruent. Notice how I do a little shorthand. I try to do shorthand as much as possible. Saves time. Do it as well. That is totally cool with me. Totally fine. Does that make sense so far, guys? Right? Pretty easy so far, right? All right. Let's do some sample problems with these two theorems. The good thing about this is we start slowly, and we build. Okay? It's kind of like a snowball. It just starts real small, but at the end of the year, you're going to have this enormous amount of information, this huge pool of information that you can just take stuff from and prove just about anything geometrically. May I continue? Thank you. Okay, boys. Given angle A is a right angle, angle C is a right angle. Prove that angle A is congruent to angle C, and they give us this figure. Okay? One thing that I always like to do is I always like to use the drawing to my advantage. So immediately I always say to myself, okay, wait. A is a right angle, C is a right angle. It's visual. Now I know what I'm talking about. Now my goal is to prove that these two right angles are congruent. So let's knock it out. What's the first thing I'm going to put down? Yes, sir. That's exactly correct. Correct. What else can I say? Okay, you're going to go above and beyond. I like that. Measure of angle A equals 90 degrees. Yeah. So let's go ahead and change these numbers here because you added a little bit more, and that's fantastic. And then definition of right angles. Correct. Excellent. Next. Sir. Yep. And then? That's exactly correct. Or definition of right angles, correct. Yes, sir. Angle A is congruent to angle C. You can come teach the class. Excellent job, son. Very proud of you. Okay? Did that make sense there, guys? Now, some of you may be saying, whoa, hold on, I'm a little confused though, Morrow. My boy just gave us 5 reasons. Why didn't you include those reasons in there, Mr. Morrow? Okay. In our first proof that we did, we went real basic. But you know already that right angles equal 90 degrees regardless, correct? And you know that if two angles are right angles, they are congruent, right? So you could go either route here. He went above and beyond. Not only did he put the givens, he explained what the givens were, and then he said, okay, two right angles must be equal. Okay, so you have a little bit of play here. There's not an exact science for the most part. It's all about how your mind is thinking, how it's bringing that information together. Cool? All right. May I continue? All right. And this diagram here, or the given in this case, is diagram as shown. Ooh, diagram as shown. What is that? What can we get from here? Yes, sir. Yes, thank you, sir. That should be J. Yes. Thank you, son. That's exactly correct. But before we can assume those two things, we've got to use our given. Because the given is letting the reader know, hey, look, I took what you gave me and I'm putting it right here. Now from that, I'm going to extrapolate all this information. So diagram as shown would really be your first line of defense. Why diagram as shown? Because that's what they gave you. It's given, y'all. It's given. Okay? Now, angle 2, exactly what my boy said. EFG is a straight angle. What's the reason, though? You had said it before. Yes. You can assume that. So you put assume from diagram. Remember that you can assume straight angles. You cannot assume right angles. but you can assume straight angles. Next on the totem pole, HFJ is a straight angle. How do we know it's a straight angle? Because you can assume it. Now, if you wanted to go above and beyond, you could say the measure of angle EFG is 180. Definition of straight angle. The measure of angle HFJ is 180. Definition of straight angle. And then you can get to, if two angles have the same measure, they are congruent. Or we can just use theorem number 2. And what does theorem number 2 state? Why is EFJ congruent to HFJ? I mean, EFG congruent to HFJ. Why? Use theorem 2. What's theorem 2? Bam. If two angles are straight angles, then they are congruent. Notice real quick the difference, though, guys. I don't want you to get confused, okay? Let me split this in 2 screens right quick. Okay. For this one, okay, we did not use if two angles are right angles, did we? Here we use a different proof. Here, I decided to define my right angles by angle measures so that I can say, hey, if two angles have the same measure, then they are congruent. But if I've already defined that they're right angles, or I've already defined that they're straight angles, that is why I am allowed to just go straight to the point. They're both straight angles because I assume them from the diagram, and oh, wait a second, that's right, theorem 2. If two angles are straight angles, they're congruent. Boom. You don't have to prove their measure because you've already defined that they are straight angles. And if they're straight angles, they're congruent. Does that make sense? Especially for you, my brother, because you've been so detailed. Does that make sense, the difference of why I would put the measure and why I wouldn't? Thank you. Sir. Because that was my given. You always write the given as the first one. Yes, sir. And then figure out, okay, what can I extrapolate from there? What can I do from there now? Yes, sir, go ahead. This is your class.
Yeah, and then can you explain that again? The reason why you put some as just straight or some as the rest.
Okay. Thank you. All right. This is excellent, and this is exactly what I hoped for. Thank you so much. I blanked it out. We're going to do it one more time. I'm going to use two different proofs here, okay? And this first proof, I wanted to prove that angle A is congruent to angle B. According to this, I know that angle A is a right angle and angle B is a right angle. So I want it's a right angle given. A measure of angle A is 90. If an angle is a right angle, then it has a measure of 90 degrees, definition of right angles. Angle B is a right angle given. The measure of angle B is 90 degrees, definition of right angles. Now, we've already learned, before we started doing proofs, that if two angles have the same measure, then they are congruent, correct? So, boom. That's what I did. However, we can condense this, though, now using our theorems. For example, let's look at the sample problem number 1. We said that angle A is a right angle, given. Angle C is a right angle, given. We don't need the measure now. Can you go the measure route? Yes. You can say that both of those are 90 degrees and that angles with the same measure are congruent. Or you could just realize, wait a second, I just learned a very powerful theorem. If I know that two angles are right angles, they are congruent. Why? Because if two angles are right angles, they are congruent. That's the theorem. Does that help you, sir? Thank you. Sir? Okay, the question was, can you just write down right angle theorem, or do you write down the definition? Well, it really depends on Depends on a lot of things. I guess you could say right angle theorem. Yes, I would allow that. Yes, sir. I will allow that. Now, here's the only problem. You're going to have about 150 to 180 of these. So the name isn't going to always fly. So just for building your confidence in this and building your strength in this, go ahead and define exactly what you're talking about. Define that theorem, okay? And then for number 2, same concept. We're going to prove this using a theorem, a new theorem that we learned. Diagram is shown. Okay, that's given. What can we tell from this diagram? Angle EFG is a straight angle because I can assume that. It's legal, mathematically speaking. Number 3, HFJ is a straight angle. That's assumed. Wait a second. I don't have to now define that their measures are both 180. Why? Because we learned a theorem. And the theorem states that if 2 angles are straight angles, they're congruent. So theorems, as much as of a nightmare it could be, my friends, it actually makes things easier. Because we didn't have to define that the measure of these angles were 180. We knew the theorem already. If they're both straight angles, they're congruent. Does that help, guys? All right. You guys are doing great. Thank you so much. Okay. So we did 1 and 2. Okay. Let's do another one now. Okay. I have got here, given that angle RST is 50 degrees. Yes, sir. No. Go ahead. You were going to ask. You were going to. Okay, let me just prep it up, and then you got it. Thank you, my man. Angle RST is 50 degrees. I'm a big believer in labeling. Huge. So write it. RST is 50. Awesome. TSV is 40. Cool beans. TSV is 40. Awesome. Angle X, the right angle. All right. I know that's a right angle. I've drawn it. Why do you draw it, Moral? It says it right there. Why are you wasting your time? I'm not. I promise you. The more you mark up your figure, the more valuable information just kind of pops up to you. Okay? So what would you think my first statement would be, my brother? Yeah. Very good. Angle RST equals 50 degrees. The measure of our angle RST is 50 degrees. Why? Awesome. What else, brother? Can I really go anywhere with that? Can that give me more information? Really? Okay, what can that give me? Wrong. Thank you so much. He jumped a big step. He said angle RST is 50 degrees, and then he wanted to say next, the sum of RST and TSV is 90. You haven't even defined what TSV is yet, brother. Okay, and remember, guys, this is a process. You guys are doing great. So that being said, what do you think step 2 would be here, gentlemen? Go ahead, say it. Angle TSV is equal to 40 degrees. Why? Given. Now, my brother, what were you going to say? Thank you very much, sir. So I kind of condensed that, and I said, okay, since RST is 50 and TSV is 40, that means that RSV, the whole kit and caboodle, is 90. Why? Simple. Think simple. Thank you. It's called the addition property. It's that simple. Keep it simple, silly. That's an engineering principle. It's called KISS. All right? Keep it simple, bro. Keep it simple. Addition property. 50 plus 40 is 90. So that means that if angle RST is 50 and TSV is 40, well, heck, 50 plus 40 has to be 90. Why? Because we learned how to add a while ago. Addition property. I'm not being sarcastic. It's that easy. Sir, you can't do the right angle theorem yet. Have you proven that that's a right angle yet? No, exactly. You guys are doing so great. Okay, you can't jump to right angle there. You first have to prove that RSV is 90 degrees. Now that it's 90 degrees, what do we know? RSV is a right angle, is it not? Why? Okay, you can't say that's what a right angle equals. What's the definition of a right angle? The definition of a right angle is that it equals 90 degrees. Yes, sir. Yes, technically we should have put M for the measure. Sorry, that's my bad. Thank you, son. Okay, I'm not too much of a stickler for that. I'm not. Just know that when you see that M, it means the measure. Okay, thank you so much for caring. You guys are great. Sir, you want to do 5? Killer. What you got? Love it. Angle X is a right angle Y, my brother. Heck yeah. Now, wait a second. Something should be just kind of vibrating in your brain. What theorem do we know already? If they're both right angles, what do we know? How do we prove that RSV is congruent to angle X? Because, no, not they have the same. No, not if they have the same measure. Thank you. If two angles are right angles, then they're congruent. Now, to go back to what my boy said, we cannot use in this case, if two angles have the same measure, then they are congruent. Did we define the measure of angle X? Or did we just define it being a right angle? Do you see where I'm going with this, guys? If I had said now, after the X is a right angle, the measure of angle X is 90 degrees, then you could have said, if two angles have the same measure, then they're congruent. But we didn't define both angles as measures. We defined both angles as right. So keep it simple. Don't add extra steps if you don't have to. Sir. Okay, on a quiz or a test, can we add extra steps? Yes. But trust me, after you're doing a bunch of these, you're going to want to not add extra steps. But yes, you may. Sir.
Number 4 and 5.
Yes. Okay. Great question. The question here is, Mr. Morrow, for 4 and 5, couldn't I switch the order? Couldn't I put this one here and this one here? Yes, but be careful. The reason that I went in this direction, the reason I flowed this way was because didn't I already prove that RSV was 90? Let's stick with the information we have. If RSV is 90, that means RSV is a right angle. Now you can get to the X is a right angle, and then you can prove it because you've proven that both are right angles. Is that making sense to you?
Yeah.
You sure, my man?
But it can also, 5 can also be in 3, right? And then everything else is
5 could be in 3 as well. Yes, again, yes it can. Everyone is going to think a little differently here, okay? As long as the facts are there, I'm not too worried about the order, but I don't want to train you a poor way. It's better to train you to show you, okay, go in sequence and show what each statement is giving you in a sequence. But the answer is yes. Sir, and then sir. Yes, yes, someone had asked that before. Could you write right angle theorem? Yes, you may. You are totally allowed. Thank you. Sir?
So what you're saying is for number 3 and 4, you can't switch them either. You see number 4 is the reason for number 4, like
Okay.
without having number 3.
Yes, okay, now that's a great question. That is a no-no. What my boy had asked before was, Morrow, can I put this one here? Yeah, you can. It wouldn't make logical sense, though. But now what you asked, sir, was very important and very dangerous, okay? He said, can I move this guy here? No. No. You cannot move that there because you haven't proven yet that these two angles equal 90. You can't have a right angle, my brother, unless you know it's 90 degrees. Does that...
And
Correct, sir. You couldn't have definition of right angle yet because you haven't defined that it's 90. So you couldn't switch 3 and 4, no. Does that make sense? Does that make sense to everybody? Awesome. You guys are doing great today. Awesome. And boom, we are done. I hope you learned a lot, guys. We're going to do some practice problems together now. And thank you.